Hello? Hello? Hello, Mr. Eric, are you right?
Yeah, I'm okay.
Yeah, okay. So remember what's the subsequence?
This something.
Okay, this one. The subsequence. What's the subsequence? Remember? Subsequence. Alright? Subsequence. What's the difference between subsequent and sublist or subarray?
Subsequent can pick like you can pick for subsequent you can pick like 2 and 3, but sublist you only can pick in continuous.
Yeah. Okay, so you're right. Yeah, sublist and subarray basically the same thing. Yeah, they continuous. Yeah. To prove for that we need O(n) squared term, right? Remember we talked about this to compute the number of the sublist for a given. Yeah, given array. If there are n element. Yeah, if there are n element of this array. And then we pick Cn1, yeah, the sublist with only one element, plus Cn2, pick 2 index, right? So that will become n times n plus 1 divided by 2, okay? And to prove for it, it takes O(n) squared term, right? But the subsequence is different. It's the original array where I did it 1 or nothing, or we did it 0 or nothing, or more elements, right? So I can remove 2, then the subsequence will be 1, 5, 3. If I remove 5, the subsequent become 2, 1, 3. Okay? Yeah? So today we want to find out the largest subsequent sum. Largest k subsequent sum. Largest k subsequent sum. Okay? So look, if this k equals 3. So I want to find out the largest 3 subsequent sum. K size subsequent. So you pick 3 elements, right? Which has the largest sum. Can you pick which the 3 element which has the largest sum? The subsequence.
5, 3, 2.
Yeah, but 5, 3, 2 is not a subsequence. What's the subsequence? You're right. Yeah, 5, 3, 2 is the largest 3 sum. But what's the subsequence? 2, 5, 3, 2 is not the subsequence
2,
of.
5, 3.
Exactly. Okay. Yeah. So 2, 5, 3. Okay. So,
How come do we have to do it that way?
That's a good question. If the question becomes if the question is that okay, pick the k largest sum, right? Then you can solve this array and then pick 5, 3, 2. Easy, yeah. So if this is array, you can just do array dot sort, and then you can just return. Yeah, I want to return this. Yeah, return what? The sum. Yeah, the sum of it. So I can just return, or I return what? ARR. Because look, array dot sort is from the smallest to the largest, right? So I can do this minus k to the n, right? Yeah, and that will give you what? That will give you what? 2, 3, 5, right? Yeah, because when we sorted this array, you become 1, 2, 3, 5, and minus 3 is at this point. Right? And look, you're with me, and 2, 3, 5. Or you can array dot sort and then you pass the parameter called reverse. Reverse equals true. And array dot sort that will become 5, 3, 2, 1. Right? And then you pick the first k. So you can return ARR up to k. So you will return 5, 3, 2. Right? But this is not that simple, right? You need to tell me the original subsequent, which is 2, 5, 3. I don't want 5, 3, 2. I don't want 2, 3, 5. Okay? Yeah? Because in this case, it'll be easy. What's the time complexity if we're calling the sort?
Log n.
Yeah, well done. Okay. Okay, so the problem, the strategy of picking the largest k is, you're right, yeah? Sorted, picking the largest. But we want to be able to locate the original index. So we want to come up with a solution to sort the numbers while maintaining its index, right? So we want to be able to say, okay, I want to pick these 3 numbers, but I also know this index is what? The 0, 2, 3. I want to pick the numbers from the smallest index to the biggest index, okay? So remember, what function in Python do we return the index and the value at the same time? Remember we talked about that a few days ago? To return the index and then the value, remember? at the same time. That's a tuple. In start with E. Enumerate, yeah, enumerate. Okay, so yeah, so we have this enumerate. That's fine. So let's do this, okay? And then you can follow my lead, so you can do it. So this is, let's say this is numbers. These numbers. Okay, so then ARR, you tell me what it is. ARR equals list, because enumerate is the iterator. Yeah, I want to convert it to a list. Enumerate. And then I have these nums. So can you tell me what's this? Enumerate, array. So array will be an array of what? Of what? Enumerate, what's the enumerate function, remember? It returns the index and the value, right? Yeah? Okay, so the index of 2 is what? What's the index of 2?
5.
Index of 2, come on, the first one.
2.
That's the value. What's the index?
0.
0, okay, look, 0, 2, that's a tuple, right? And then 1, 1, right? And then 2, 5. And then can you tell me the last one? 0, 1, 2. And the last one is?
3.
Yeah, okay, so that's what it basically does. Enumerate has the index and the value, which is a tuple. I converted the list, so that's the left. So I want to sort this number, but I want to sort it by the value, like the second key, right? So I can do this. Look, this is the magic. ARR.sort. Right? I want to sort it, but I want to give it a key because it's a tuple. I need to take a key. Key equals what? Equals lambda. Yeah, lambda is a short function x, and then I want to do this x1. Right? X is here. X1 is the value. I want to look. Basically, this is to sort this ARR array by the second value, right? By the second value. But of course, this I want to maintain the index. This is the index, right? Yeah. Okay. So now I have this. Okay. This is the comment. Okay. So I've sorted. I can also sort it in the reverse order, which I put the what? Put the key equal reverse equals true, right? Now I want to get the index, right? So index equals I, right? Look, index, what's the index? So look, if I sort it, and then that will become, I sort it by key, so that the ARR will be the value. The first 3 values will be what? The first 3, so that will be 1, 2, 5, 3, right? 1, 2, 5, 3. And now 1, 2, 5, 3, so you'll be 1, 1, 2, 5, 3, 3. Actually no, 1, 3, 1, 1, 2, yeah, 1, 0, 0, 2, 1, 2, the second value, yeah, and then 3, 3, and then 2, 5, right? I want to sort by the second value, and then this is the sorted. So I want to get the last list, the index will be 0, 3, 2, right? So index, so will be I for I, comma j in ARR, right? ARR from minus k to the n, So that the first index will be 0, 3, 3. So index will be 0, 3, 2, right? So now I need to sort the index again, right? Index.sort. Yeah, index.sort will return 0, 2, 3, right? And then I need to just return what? Return. I have the index, and I want to use the index to retrieve the value in the numbers. So I will say nums I for I in index. Right? Make sense? Okay, makes sense. Okay, so let me repeat, okay? You just follow my lead. First of all, I go list. AR equal list, and then I have this thing. The first element of the tuple is the index. The second element is the value. And I saw the array, saw this thing by the first key equals x1 by this. So you tell me the sorted array will be 1, 1, 0, 2, 3, 3, 2, 5, because I sorted the last value, yeah, by last value. And then minus k2, so I get these 3 paths, which is 2, 3, 5, but I want the index 0, 3, 2, right? This index will be 0, 3, 2, and after sorted it will be 0, 2, 3. And then I go through the index to get the index, to get the index from the original number. which is 0, 2, 3. So which is 0, 2, 3? 0, 2, 3, 2, 5, 3. Got it? Make sense? Time complexity. Sorted. Sorted ON. Sorted ON. Right? ON log n. ON log n. So 2 ON log n. Okay. So the complexity is 2 ON log n. But of course this K, I need to assert, yeah, we need to assert this K thing. Assert K is bigger than 0 and smaller than the length of the, smaller than or equal to the length of lambda, okay? We don't want to deal with negative K's or the K bigger than that. If K is a million, right? That doesn't make sense, right? Yeah? Okay, so this is one way. The second approach is that we can do this using a window, sliding window, a window thingy. So again, is this the, okay, let's consider a bigger example, okay? The numbers equals 3, 5, 2, 1, 7, 6, and K equals 3. Okay, what's the largest, Eric? What's the largest subsequent which has 3 elements? The sum.
It is 5, 7, 6.
We're down 5, 7, 6. Yeah, you sorted the number, then you pick the largest, the smallest one. Look, this question is easy for human, right? It's easy for us to do it, right? Alright? We just sorted, pick the largest 3 numbers, which is 6, 7, 6, 5. And then the subsequent will be 5, 7, 6. Easy, yeah? It's very easy for us to find this solution, but maybe a bit tricky for computers to do it, okay? So look, K equals 3. Let's maintain a window of 3. So the first window of 3 is 3, 5, 2, right? This is window 3, 5, 2. Okay, and then now I am starting at least. What's the minimum of this?
2.
Okay, is 1 bigger than 2?
No.
No, then I don't. We just skip it, right? Because if this is smaller than the minimum, it means that we don't pick this one, right? Because this one is even smaller than the minimum of it, right? There's no point to replace any of element with this a smaller one, right? 7. Is it smaller? Is it bigger than the?
Yeah.
Okay, so what do? I remove the minimum, and I replace it with 7. I append it to the end, right? Which is 7. Okay, 6. What's the minimum?
Sorry.
I remove it and I put it at the end. Okay, 5, 7, 6. Yeah? Original. Got it?
Yeah.
Okay, this is sliding window. It works. Why? Because every time we get the minimum of this wing, right? And if this number is bigger than the minimum, so we can replace it, yeah? Right? For a better solution, am I right? Yeah, that's a greedy solution, yeah? Okay, so let's do this, and that'll be it. And you need to tell me what's the time complexity. Think about it, okay? Define, let's say, largest K subsequent. And then we have numbers, we have K, and obviously we need to assert this K thing is bigger than 0, smaller than length of num. Okay, the window thing. Window will be, at the beginning will be nums up to K, right? And then for I in range. Range what? Which index we need to start, Eric? Which index we need to start?
We need to start from the first one.
No. The first, which element? We already have the first window. K, yeah. And up to length n, right? Okay. And then look, this is current minimum equals, we can say mean of the window. And then look, if nums, if current element is bigger than the current mean, right? There might be multiple solutions. We just return any one. Look, if these 2, 3, actually, okay, 2, 3, 4. If they are duplicate element, what happens? So 4, 4. Okay, there is no duplicate element. If the duplicate element, we need to put an equal sign. Should we put an equal sign there? If this, the pick the largest 2 is 4, 4, right? It's 4, 4. It's 4, 4. Yes. So if it's bigger, okay. If it's bigger than the smallest one, right? If it's equal, we don't replace it because we can't find a better solution. It's a same solution, so we don't replace it. And if it's bigger than the current minimum, then we do what? We can do this window dot remove the current element. Current minimum. We remove it and then we need to append it to the end, right? Append. Alright, what's it doing?
Pancakes.
Append current ri, yeah? And then at the end we return win. Okay? Okay, let's try with the duplicate because I'm not quite sure. Let's do this. 3, 2, 2, 3, 2, 1, and k equals 2. Okay, what's the k equals 2 in this case? K equals 2. Pick the largest.
3, 2, no,
2, 3 or 3, 2. It doesn't matter, right? You can return anyone. Okay, so let's say this window 2, 3. Okay, 2 is bigger than the minimum. Yeah, if it's bigger, then we replace it with 3, 2. Okay, it doesn't matter. If we put an equal, if we put an equal, that will be 3, 2. If we don't put an equal, it will be 2, 3. Okay? Why is that? If it's equal, look, when we find the second two, Eric, if it's equal, then if it's equal to the minimum, we remove it and replace it. Append it will become 3, 2. If we don't replace it, it will still be 2, 3. Okay? What's the time complexity?
Time complexity is n.
Here is n, O-n. But, look, finding the minimum here. Finding the minimum, this window is k, right? O-n times k. And remove it. Remove one element. Look, okay. List. Eric, let me do this. Eric, come on. ARR equals 1, 2, 3, 4. And then ARR dot remove this operation. Remove 2, for example, yeah? Remove 2, then AR will become 1, 3, 4, yeah? Easy. Yeah? But if I remove a non-exist element here, if I remove minus 2, then the computer will scream. Because this minus 2 is not in the list. Yeah? Max, what did I just say?
If you do like a negative number, it will scream.
It's not because it's negative, because this is not in here, right?
Okay, yeah.
Okay, so what's the time complexity to remove this? It's O-n. Okay, so this is O-n as well. O-n, but this is k, because look, this window is k size, yeah? This fixed size. Okay, it's a fixed size. Every time I remove it, I append one. So it's always k as fixed size. So this is still O-n as well. So altogether is what, Eric? O-n, okay, so altogether.
O-n and k.
O-n, k. Which is bigger, O-n log n and O-n, k? What do you think? Which one is bigger?
It depends.
That's a good question. That's a good point. But if you think about it, yeah, because if you look at it, k and log n, you're not sure which one is bigger. That's a very good first point. But in this case, is k smaller or bigger than n?
Smaller.
Where down? If it's smaller, okay, let's say if it's at most is n. Okay, so if it's at most n, let's say O-n, okay? O-n square. O-n square lower than k. Which one is bigger?
Wait, O-n square and O-n log n. O-n log n.
Yeah, of course, yeah. Because we know k is smaller or equal than n, right? Yeah? So let's say, okay, in worst case it's n, right?
Yeah.
But in worst case it's n. If it's n, then we don't need to continue here, right? Because look, if given this side, the largest k size is XL, right? Yeah? Yeah? Okay. So if it's worst case is O-n, then obviously this is better, okay? This is better. Right? If we don't consider about that thing, we're just considering these two things, and k is smaller than n, and onk is the on log n is better than onk, right? But actually, if k, so look, k is for example is roughly n divided by 2, right? If n divided by 2. I don't know. We can put let's say we can put 100 there, right? 100. Divide n is 100. K will be 50. O log 100. Yeah, still better than k equals 50. Okay. So yeah, clearly this is the winner. Okay. Yeah. Any questions so far?
No.
Okay. Say bye bye to people.
Bye.
Bye bye.